before we get any more delayed, I think almost 20 minutes past the time. Let's go ahead and get started. In case you guys have any issues, please just comment on the thread. I will expect people still have the. You will not be able to see me. You should be able to see the presentation. You guys can see the presentation, right? That's what the goal is. Okay, so let's go ahead and get started. So today's agenda is we will be talking about big data for a while. We would be, just a brief overview of what big data is, what is the business perspective of it, and what is the technical perspective of it. We'll do a little bit of introduction about the GPU. We'll compare how the GPU stands against the CPU and what is the architectural difference of a GPU versus CPU. Most of you have heard, most of you have heard about GPU, especially जो लोग गेम खेलते हैं. I'm sure बहुत लोगों ने GPU को use किया है and you bought GPUs too. But I'm not sure how many people actually aware of how the GPU works and why there is a separate GPU and हम लोग CPU से क्यों नहीं we do all the processing. So yes, we'll do a quick overview of what is the difference between a GPU and a CPU. We'll head on to our core topic for this today's discussion, which is GPGPU. We'll dig into a little bit of programming part of the GPGPU, specifically talking about NVIDIA chipsets. So there are lots of chipsets available in the market, but specifically हम लोग GPGPU का जो discussion है वो NVIDIA के लिए करेंगे. And follow after that the most critical section of today's discussion, hands-on session, which is a small 10-minute session जहाँ पे हम थोड़ा सा कोड लिखेंगे. We'll just write like 15-20 lines of code और उसमें we'll try to find out the difference. What would happen if we use only a CPU, जैसे हम लोग traditionally जैसे भी code करते आते हैं, and उसके बाद what would happen if we try to use somewhat like what we discussed in today's talk. And you will see that there is a huge difference in terms of not just the time but also the reason why we do these things and why we have not been taught all these things in high school or in our college. And we'll be following that with a very brief question answer session. This can go till like as long as you have questions. I don't mind. Let's go ahead and get started. Most of you know me, but in case you don't know me, my name is Aniket Bera. I am a researcher in the graphics lab at University of North Carolina at Chapel Hill. I have worked with many startups and corporate research labs, and most of them most of the labs which I worked on are typically in the graphics domain. Some of them are like Disney Research, Intel Labs, or Boeing. And most of my research, which I do here at UNC, is funded by the NSF and the Department of Defense. So what are the prerequisites to this talk? I'm sure most of you, we've already discussed this before, so there's not a lot of prerequisites if you want to listen to this talk. You might need a very, very, very basic overview of basic knowledge of C or C++. And if you want to program, you definitely need some background with C++. You definitely do not need any GPU experience before. You definitely do not need any parallel programming experience before, and you also do not need any graphics experience. So let's head down to the reason why we're doing all these things. What is big data? So big data is, you've all heard it from different channels, different avenues. Big data is a hot topic in the market today, and it's any research organization to take advantage of this huge pool of information that is coming to us. And big data itself is not new. It has been here for a while. It's been here for years and years, and it's still growing exponentially. But what is new? The reason हम लोग अभी ये GPU की बातें कर रहे हैं, what is the reason why big data is so important आजकल? It is the reason that now we have the technology to realize and process it and to analyze lots and lots of data in almost real time for interactive applications. The purpose of big data is to effectively manage and analyze all the available data, any data that is. So it can be structured data, it can be unstructured data. And the reason why big data is also very important is because the unstructured data has been growing lot, a lot. When I mean unstructured data, I mean data which doesn't have any information, apparent information attached to it. So let's say you have text files. So text files where you have text, you can understand, you can parse that text. और उससे हम लोग meaningful information extract कर सकते हैं. But let's say we are let's say we are discussing something like YouTube video, something which doesn't have any apparent tagging to that. So that information itself is not related to anything. So there's a huge overflow in terms of the unstructured data. And because of such large unstructured data, we definitely need something to analyze the content. So a lot of people think that big data is just about Hadoop. I mean, I'm sure most of you have heard about Hadoop. If you haven't, like, we'll cover Hadoop in one of the. Okay, I have a question. And NoSQL is unstructured data too? Yeah, I mean, I'm sure many other folks can correctly answer this. I'm not a very good, I don't, I'm not correct. I'm not sure about the answer for that, but I think it is unstructured. If anybody has an answer to that, please. Okay, Tina says yes, it is. Perfect. I'm really sorry, guys. I haven't used databases for a long, long time, but yeah. So there you have it. So that is the reason we wanted to have it interactive, like तुम लोग भी बात करो. But next time, I'm sure that have a much better way of presenting these things, and hopefully Google Hangout will do Google Hangout, like the live thing. It's much more better. Okay, so one of the key requirements for big data is to not just store data. And it's for a long time, big data was only about storing data. Let's say you see the screen right in front of you. You have websites, you have science-related applications, you have ERP solutions. Wait, okay, so yeah, you guys go ahead on that discussion. I will carry on with the slides. But of course, if you have any questions, let's keep them to the end of the session. Beach my questions, feel free to ask. But if you have like discussion-related questions, yeah, we can have that. We can all discuss afterwards. So yeah, let's say Facebook, Twitter, network switches, and all these things. Uh, yeah, so all these things are basically a pool of a huge amount of data, and a lot of it is still unstructured data. So storing it was definitely a problem many years ago, but abhi the problem and our problem statement has changed to not just storing it, but to analyze lots and lots of data. So Hadoop is definitely, so new technologies have emerged that discovers, indexes, searches, and navigates diverse sources of data. One big data like we've discussed is Hadoop. So Hadoop is basically a collection of a lot of open source technologies, and it's still a very good tool, if from an industry perspective. But the problem with all these technologies are it's still limited on the basis of how much on the architecture of the solution. I mean, the solution, you will have a lot of processing involved. So you use a lot of computers, you use clusters, but essentially, end of the day, your compute is restricted by the amount of hardware which you have, and the number of processors which you have. So even in like big systems, big clusters, and all these things, it is definitely definitely the number of processors which directly correlate with the amount of processing which you do on this big data. So today we are going to move a little bit ahead of that. We're going to talk about not just CPUs, not just the logical processors, which as we know we're going to talk about a lot of things which come from the graphics domain, and how we apply those things to big data processing. Here are some of the domains which definitely have like a lot of supercomputing, which requires supercomputing, and let's say computational geoscience, computational chemistry, computational medicine, modeling, physics, biology, finance, and of course graphics, image processing, and vision related. So all these domains have tons and tons of this. These are like academic domains, right? So I'm not even talking about the business ERP solutions and stuff like that. Even in this academic domain, there's lots of sciences, lots of finance related applications which use a lot of data. But again, unfortunately, those data we don't know how to process that. And whatever exists right now, what existed like 5 years ago was not good enough. So Welcome to the world of computer graphics. Just to give you an iterative idea of what computer graphics and why I am talking about computer graphics in a session on big data, it will become clearer in just a bit. So, computer graphics is all about, it's actually a lot of things together. It's about rendering, it's about making visuals look very good. So, the image which you see on the left is a artificially rendered image of a human face, and this has the most high-end physics and mathematics applied on it. So this probably has a million different computations which was calculated. We do a lot of simulations, a lot of space research, lot of art simulations in computer graphics. It's all about mathematics and physics. So you can understand. Okay, so of course, there are people who don't have any audio. I don't know how to help them with it right now. We also do crowd simulation. This is what I do specifically. I simulate lots and lots of crowds in real time. So when I say crowd simulation, it is basically trying to understand how people move, how people behave in a very tense scenario, and trying to simulate that. And also animation. Of course, we've all seen good movies from Disney and Pixar. So all these realistic looking animation movies. It's sort of a graphics. So what graphics essentially is a form of computer science mixed with art, physics, and maths. So how exactly is this correlated to GPUs? Well, whenever you have images, when you see images, when you see graphics, every pixel on the screen, has a computation involved with it. It might not have a lot of computations as compared to a mathematical equation, but let's say you have a huge screen with 1080p resolution. Every pixel has its own color computation. So graphics essentially, end of the day, boils down to what you see on the screen, and what you see on the screen is essentially hundreds and thousands of calculations which are going on at the same time. Again, that said, those computations are small. They're not very big matrix multiplications or something. So there I've used Maya and graphics and simulation. How can we leverage? Okay, so we have a question. A person has used Maya and graphics and in rendering and simulation. How can we leverage this for some other processes like big data? So that's what I'm coming to. So you see all those applications like Maya and 3D Max. They become really fast when you use graphics processor, right? And there's a reason. That's why, because every pixel, a lot of computations are happening. Small computations are happening pixel level. So uh, it's essentially a lot different from a CPU, where exactly mesh and polygons, these computations are billions and billions of computations, and they're happening many of them happening independently. Let's talk a little bit about what the difference is now. Then we can go ahead. Okay, so there's a difference between a CPU and a GPU. On a CPU you have, let's say, 4 cores. Let's say I don't know how many of you are computer science guys, but many of you heard about like quad cores or dual cores, right? So essentially, what those things are, those are 4 CPUs or like 2 CPUs. So उसमें ALU unit, जो if you see the image on the right, on the left, you'll see a typical CPU would have 4 processors, quad core. Some of your laptops might have a dual core. So let's say 2 CPUs. It'll have a huge RAM and a huge cache and a huge control unit. But on the GPU, since we know that हमारे calculations छोटे हैं, definitely very small, but there are many, and a lot of them are happening in parallel. Since on the GPU you have thousands and thousands of ALUs. We have a shared DRAM. We have एक जो memory unit है जो सब में common है, but we also have individual level memory. हर row में you see there's some cache in it, some memory in it. So you see the contrast between a CPU and GPU. Definitely, there's a lot of usage for a CPU unit, like complex mathematical equation. But if we can split our task, जो भी हमारा goal है, जो भी हम so again going back to big data. Big data is mostly processing lots of independent data, lots and lots of independent, and those processing can be very simple. Like अगर हम individual level पे देखें, तो maybe it's just 1 + 1 = 2, right? But ऐसे billions of calculations होंगे. So if we can split our tasks sufficiently कि वो छोटे-छोटे tasks में, okay, you said okay, so Nishant has so let's say let's talk about matrix multiplication for example. So मैट्रिक्स मल्टीप्लिकेशन में you let's say you have दो n cross n के matrices. अब उसमें बहुत सारे calculations हैं जो you do not need the previous output for it. So मान लो x I mean you know matrix multiplication, right? So उसमें you can do बहुत सारे independent calculations like a into b plus b into c plus ऐसे से कर करके जो नया मैट्रिक्स बनता है you do a lot of independent calculations and a lot of small calculations. So yes, the bigger goal is huge, the big data processing is huge, but if we can sufficiently break down that process into smaller chunks of tasks, maybe I'm not, I mean abhi we don't know as of now, maybe GPU is good enough for it. So let's move on to see what exactly did we learn from the GPU. GPU has thousands of cores compared to let's say 4 or 8 cores on the CPU. ठीक है, I don't think so. अभी 8 core computers are very common right now. I mean I haven't seen one. I mean I haven't seen on a desktop PC. Maybe, of course we have 16, 32, 64 cores in our labs, but mostly 4 to 8 core PCs are very common these days. A single thread is executed very quickly, whereas a GPU, many concurrent threads, like many concurrent processes, can be executed at the same time. So traditionally, this excels for embarrassingly parallel tasks. When I mean embarrassingly, like there is nothing in common between the 10 tasks, between the million tasks which are doing. So, so you can see the reason why we need something which is very parallel in its core, in its fundamental. CPU में you can execute a lot of single threaded but very complex, like very memory intensive चीजें, तो उनको CPU में करना अभी भी it is better. How okay, I have a question. How is synchronization is maintained in multitasking? Why GPU threads are slow? Oh, so GPU threads are. So there are many reasons behind this. I mean, I don't think so. I should get into technical details right now, but okay. So let's keep those questions for the end because there are a lot of folks who don't have the background in terms of the OS architecture. But yeah, typically GPU का जो single core है, it has a very small cache and a very small memory. So and also it's the goal behind a GPU thread is. Yes, so that's in short that is the reason. And the question is how is synchronization maintained? I'll come to that. That's a very good question. That's a question which we will discuss when we're actually programming. Okay, so let's go ahead. So yeah, so you can see that GPU and CPU have complementary properties. दोनों में कुछ तो benefits हैं जो एक CPU में है एक GPU में नहीं. So definitely we need an application which uses both the CPU and the GPU at the same time. अपने बड़े से application का कुछ portion may be very good for GPU and कुछ portion which you seem like कि उसमें there's a lot of sequential things happening, like parallel कुछ हो नहीं रहा तो उनको CPU में डाल दो, और जिनमें you see very small level things but they are happening at the same time तो उनको push it to the GPU. So a lot of GPU, so this GPU concept of accelerated applications is very important. What you can do is write 10 lines of code, put 3 lines to us. I'll just actually come to that. Let's go down. Let's talk about the history of GPU for just knowledge reasons. So GPU stands for General Purpose GPU Computing. We all know that GPUs were invented for graphics, right? But now we see that the fundamentals behind graphics are now also applicable to lots and lots of big data calculations. So maybe we can use GPU for general purpose computing. So the research started here at UNC way back in 1998. This was the term GPU was coined by Mark Harris in 2012 while he was still a graduate student. So I mean, he didn't even get his PhD by then. It's sort of a very encouraging and inspirational thing for most of the students here. Well, okay, I have a question on GPU. Do the threads actually run parallel? Or just oh yes, the threads run parallel because there are lots and lots of codes, and that is why they run parallel. Whereas CPU would have just 4 cores. Is it clear? Because you just saw the difference between. So
Hello.
yeah,
Actually, I read that uh, it they don't actually they don't run parallelly in actual scenario. I mean,
No, they
they just
actually
switch
run parallel.
very
They
fast.
have they do all the computations in parallel. If you see the difference between a GPU, they have thousands and thousands of if you have so the point is there are limited number of cores in GPU too, right? They're like 1,000, 2,000 depending on what GPU you have. उससे ज़्यादा if you put, then of course it will be like time sharing or whatever you want to have, like uh, um, scheduling tasks, however you want to do it. So when you have so many cores in the GPU, all these computations run in parallel. You see the difference between the green ones, right? Those are independent
Yeah.
ALU.
But what about those threads that run, like, for example, in uh, threads or something, those libraries, they also run parallel. I'm not
Which
sure.
threads? I'm sorry, which threads?
Can't remember the name. The threads that we use in OS, in Python threads, thread
I mean,
library.
I'm not entirely sure about what exactly the thread you're talking about. Maybe so the thing is, if you want to have threads in parallel, you can have it on the CPU as well, right? You can instantiate thousands of threads on the CPU.
Yeah,
But
but
since
do
we
they actually run parallelly or it's just the switch? Like, in very
no, no,
small
no.
interval, the switch.
On the GPU, it will run parallelly. On the CPU, depends. So it all depends on the number of cores you have. On the CPU, you have only four cores. So चार से ज़्यादा करोगे, then वो split होगा. Otherwise, चार तो parallelly कर ही सकते हैं, right? Same on the GPU. If you have a million threads, it won't run million at the same time. It will only have जितने number of cores हैं, and उसके बाद वो फिर repeat कर I mean, it will schedule on its own.
Okay, okay. Good
ठीक
now.
है. चलो चलो let's go on. So what so he graduated in 2003, and like he had coined in 2002, and when he graduated uske baad Nvidia hired him, and right now he's the director of like the whole program, like I think one of the chief something of the program. And 2007 Nvidia launched their first CUDA programming language, and that was essentially for writing programs on the GPU. उसके पहले यू कुड राइट इट लाइक 2000 सो 1998 में लोग लिखते थे हमारे लैब में भी, जैसे डिस्कस मार्क हैरिस आल्सो यूज्ड टू राइट. बट द पॉइंट इज हम लोग एक हैकी मेथड वी यूज्ड टू क्रिएट अ पाइपलाइन थ्रू द ग्राफिक्स पाइपलाइन, और उसके अंदर से हम लोग यूज्ड टू try to hit all these separate codes. But CUDA आया, NVIDIA लाया, and like the thing changed completely. Industry. If somebody turn off, let me mute off. Can you hear me now? I'm sorry, I muted myself as well. So okay. So yeah, मैं कहाँ था? In early 2010s, Apple and Intel brought okay ठीक है, it's okay. Smiley से please speak now. So yeah, Apple and Intel started with their own open source OpenCL GPU programming language, and abhi it is almost like an industry now. Everybody, all the big industries, all the big supercomputing labs, they don't just have CPUs; they have a lot of GPUs. So present day scenario, it is now industry standard for using like all government labs, every like big supercomputing lab, even in India. I don't remember, but last I heard that like these क्या हो गया? Okay, I'll mute Vivek. Don't worry. Okay, I muted Vivek. Men will be men. Okay, that was really अच्छा. हाँ, तो as I said, it is the de facto method used in supercomputing these days. So let's see थोड़ा सा code, like let's talk about, let's see have a huge application code, 50-60 लाइन जो भी है, 50,000 लाइन. So there's bound to be a lot of code which is sequential, जो you cannot parallelize. ठीक है, तो उसको definitely still do it on the CPU. there will be at least like 80 to 90% of the code जो CPU पे ही चलेगा. But your bottleneck might be a small part of the code which can be easily a very compute intensive part of the code जिसको हम parallelize कर सकते हैं. तो उस पर्टिकुलर सेक्शन को जीपीयू पे डाल. सो इट्स एज सिंपल एज इट्स नॉट लाइक कंप्लीटली हम जीपीयू पे सब कुछ कर रहे हैं. इट इज आर सेम सी प्लस प्लस और सी कोड विच वी हैव डन, बट दो तीन फंक्शंस विच वी फील दैट ये तो बार बार कॉल हो रहे हैं एंड इट्स बीन यूज्ड सो मेनी नंबर ऑफ टाइम्स, उसको पुश इट टू द जीपीयू. सो दैट इज द गोल अबाउट the GPGPU or say heterogeneous computing. So we are done with why sequential code inherently slower on a GPU. Yes, because the GPU. So let me in a very brute force way. जो GPU पे जो cores हैं, the cache, they are very small, and the goal for a goal of a GPU was not to do lots of intensive processing. The goal was the GPU was to do processing for a graphics related application. और graphics में the goal is छोटे छोटे pixel level के computations are very small. So it was designed in that way. इसी reason से GPUs are very friendly in terms of your वरना तो इवेंचुअली फिर तो सीपीयू बन गया ना. बट हम लोग इंडिविजुअल कैलकुलेशंस को छोटा रखें बट बहुत सारा रखें. सो इट ऑप्टिमाइजेस ऑन टाइम एंड इट ऑप्टिमाइजेस आल्सो ऑन द क्या बोलते हैं एनर्जी कंजम्पशन. एंड एनर्जी कंजम्पशन इज अ बिग प्रॉब्लम दीस डेज. लाइक आई थिंक वन ऑफ द बिगेस्ट प्रॉब्लम इज एनर्जी कंजम्पशन. इन सुपर कंप्यूटिंग लैब्स आर इट्स megawatts and megawatts of energy is consumed. So GPUs का यही है, when you divide your work substantially, it reduces your exactly. So okay, I don't need to explain. Perfect, thank you guys. So yeah, combine both of them, combine the GPU and CPU for a mixed heterogeneous computing. So we are done with the part of the थोड़ा बहुत जो इस presentation का जो मेरा goal था. But now let's go to the programming part of it, and this is where things start to get interesting. So if you are on in the session right now, please do not leave. Uh, CUDA, let's. So अभी मैं जो भी discussion करूँगा वो CUDA related है. So CUDA में ये है the host. So there's some terms we need to learn. The host is basically the CPU and its memory, and the device is basically the GPU and its memory. So दोनों devices दोनों जो चीजें हैं, मैं अपने CPU और उसके साथ जो associated RAM है, मैं उसको सॉरी the memory है उसको मैं host बोल रहा हूँ, and device को मैं GPU को मैं अपना device. तो GPU खुद भी memory है, so the whole thing is called the device. Just learn it because it's a term. It's both of them are actually devices, but just for the sake of CUDA programming, these are terms which we use. Okay, again, this is like a repetition of what we discussed. इसमें है कि there's a lot of serial code, a lot of parallel code. So and we also have a parallel function. I'll go down to that little bit थोड़ी देर में. So हाँ, एक ही code में there could be a serial code which is executed on the CPU. There could be a serial code which is executed like एक के बाद एक, and there could be a small section which is multi-threaded, like huge number of threads working in parallel on a GPU. I'll come back to the code. Actually, we will be trying to write similar code. देखेंगे कि वो कितना scale up होता है. ठीक है, so let's talk about the whole flow. बहुत आसान language. पहले अपना जितना भी input data वो CPU memory से GPU memory में copy करो. जितना भी चाहिए. You don't need to copy the whole thing, but जितना भी memory you want for the parallel processing, just copy them. Second, load the GPU program and execute on chip. पूरे chip में उसको execute करो. And then I simply copy the results from the GPU memory back to the CPU. Very simple. There's no, I mean, there's lots of things going on in the background, but मैं अभी बहुत ही simple language में, you have to copy the stuff to the GPU. GPU के साथ कोई synchronization वैसा नहीं होगा. Explicitly PCI bus जो cable है उसके through it goes to the GPU, वहाँ process करो, जो भी result उसको वापस ले आओ CPU because you need to see your results. Can you repeat what you said? Okay. So it's there on the screen. I didn't say anything. Yeah. So when you when you copied stuff to the GPU पे वो जो processing है, do the processing. जो भी processed output है, like whatever you computed, calculated, वो GPU पे रह गया, उसको वापस copy करके back to the CPU level. Because anyway you need to see from a CPU's perspective. GPU पे जो हुआ तो हुआ, but CPUs are the thing which are connected to your program essentially, right? So that's as simple as that. There's nothing in it. Perfect. So let's write a very, very small hello world application. I'm sure you've written thousands and thousands of hello world applications. एक मिनट बहुत सारे. Okay. So I'm guessing there's a lot of questions on Facebook, and I have uh, I'm a bit confused. I'm sure many people are not able to join for many different reasons, but let's just go ahead. Uh, you guys can totally understand this small section of code, right? It's int main printf hello world or return zero. It's like बचपन से हम लोग यही करते हैं, so there is nothing special about it. Now let's try to write uh, it's a standard C that runs on the host. Standard C runs on the CPU. अब इसी चीज को मुझे डिवाइस पे लिखना हो तो मैं कैसे लिखूंगा? इसको इसको बहुत ही केयरफुली पूरी चीज को देखो. You have the same function int main. For the moment forget the ऊपर वाला जो लिखा है int main void, ठीक है. अब मैं कुछ तो कॉल कर रहा हूँ माई कर्नल और फिर ट्रिपल ब्रैकेट्स के अंदर वन वन करके उस फंक्शन को मैंने कॉल किया. ये माई कर्नल अगर देखो ऊपर देयर द फंक्शन राइट void my kernel void. Are there any thread scheduling algorithms on the GPU? Yes, absolutely. Like there's lots and lots of thread scheduling applications. We might not talk about them today because that's like a little higher level of GPU programming, but definitely in the following sessions. ठीक है. सो बट यू सी दैट इस कर्नल में कुछ तो अजीब चीजें हैं, राइट? क्या क्या अजीब है? एक तो ये ग्लोबल वाला सामने चिपका दिया. यू probably would not have used this before, a global keyword. And secondly, you might have seen मैं my kernel function को मैंने कॉल किया उसके ये ट्रिपल ब्रैकेट्स जो है ये सब क्या है? ये सब चीजें different है. Let's go on to see what those things are. There are two new syntactic elements in this. Them is the global thing before your function name. So global is a keyword which indicates, which tells the compiler या जो भी है उसको बोलता है कि भैया ये CUDA का है, ये GPU पे ही रन होगा. तो उसको पहले से बता देता है कि ये फंक्शन अगर कॉल करो उसको GPU पे रन करो. So it is runs on the device but it is called from the host code. Host code बोले तो अपना जो normal C++ code which runs on the CPU, ठीक है. सो CUDA कंपाइलर वो सेपरेट कर देता है दोनों कोड. अगर मान लो डिवाइस के फंक्शन जैसे फंक्शन आगे ग्लोबल लिखा हुआ है, इट विल बी प्रोसेस्ड बाय द एनवीडिया कंपाइलर और इंटेल का कंपाइलर जो भी कंपाइलर वॉइड मेन है कि नॉर्मल फंक्शन है तो वो नॉर्मल अपने स्टैंडर्ड कंपाइलर पे रन होगा. ये सुडो कंपाइलर है, इंटेल का है, जीसीसी है, व्हाटएवर द केस may be. And the new thing is this function called the function called my kernel. It doesn't have a triple bracket. This is essentially called kernel launch. For the moment अभी के लिए ये वन वन हम छोड़ देते हैं. हम बाद में देखेंगे कि वन वन का क्या मतलब है, इसको क्या चेंज करना है, what is the point. So this that is all that is required to execute a function. Can you repeat the last line once? Sure. Of course. You mean this one? Okay. So let's forget all these things. You've seen this code, right? इसमें दो कौन सी चीजें हैं जो different है from your normal programming. You've seen the slide before, right? हम लोग void main कैसे लिखते हैं. तो तुम लोगों ने देखा होगा कि एक तो हमने कर्नल करके कोई फंक्शन लॉन्च किया. तो माई कर्नल 1,1 ये ट्रिपल ब्रैकेट्स के अंदर और उस फंक्शन को कॉल किया. ये ट्रिपल ब्रैकेट्स क्या चीज है? समथिंग न्यू, राइट? सेकेंडली जो ऊपर फंक्शन लिखा हमने माई कर्नल उसके पहले हमने ग्लोबल कीवर्ड चिपका दिया. There is a reason behind this. Now, why do these two things exist? जो global वाला है, that tells the compiler कि भैया ये जो code है, ये जो function है, ये GPU पे run होगा. So definitely don't try to compile it on your on your CPU. So इसको जो भी इसके अंदर है, इसको push it to the GPU. ठीक है? And secondly, my kernel के अंदर जो triple brackets है, that is used to invoke the GPU code, the GPU function for in this case. So 1,1 जो भी लिखा है उसको फिलहाल के लिए भूल जाओ. अभी हम उस पे आएंगे थोड़ी देर में. So 1,1 का क्या मतलब है? What does it like? What exactly does it? So let's go to the next slide. And इसमें only thing which probably would have confused us is कंपाइलर्स. जो मैं लास्ट में जो दो लाइंस है इसमें है कि जो माई कर्नल है वो अलग कंपाइलर, वो प्रोसेस बाय द एनवीडिया कंपाइलर. और जो मेन फंक्शन है जो अपना डिवाइस जो होस्ट कोड पे है वो अपने स्टैंडर्ड है. विजुअल स्टूडियो में चलाते हो तो विजुअल स्टूडियो कंपाइलर है, इंटेल का कंपाइलर है या जीसीसी है, जो भी कंपाइलर यूज करना चाहते हो. सो दैट विल बी अ स्टैंडर्ड कंपाइलर. बट जो जीपीयू वाला है वो जीपीयू के कंपाइलर्स पे चलेगा. वो ओपनसीएल है तो ओपनसीएल, अगर वो एनवीडिया है तो एनवीडिया. ठीक है, चलो लेट्स गो. I don't think so CUDA has a full form, but you might just Google search. इतना नहीं पता. I'm not sure, but it's basically a programming API for NVIDIA GPUs. Uh, so let's look at the whole thing again. तो इसको चलो एग्जीक्यूट okay. So yeah, simplified. Okay, so perfect. Shobit has the answer for it. I thought when you were explaining host and device, did I miss anything important? I don't think so. But if you think that you don't know what host and device is, I can repeat exactly. So there's Saransh is absolutely correct in this. There is nothing which is कुछ भी नहीं करना, right? Voice breaking. Okay. Uh, I shouldn't break. Actually, maybe check your internet connection for that. Uh, so my kernel actually does nothing. It's somewhat anti-climatic because अपना print भी कर रहा है and it calls the GPU for doing absolutely nothing. Right? So let's try to think of something which is more. But the goal of this Hello World application is to invoke the GPU. GPU को बुला के फिर the point is अगर ये execute होता है इसका मतलब है कि वो GPU पे गया कुछ भी नहीं किया उसने कि वापस आया and then printed up. अगर नहीं होता then it might have printed an error as well. So you can. I mean I'm not sure about that, but definitely if you execute this correctly it will print hello world. Okay, now let's actually go to why we are here, right? We've done all these things, hello world, ये सब बकवास follow करते रहते हैं, but GPU computing is all about massive parallelism. It's about big processing lots and lots of data. So why exactly are we just doing like one hello world? There's bound to be some simple example which makes more sense. So yeah, we definitely need a little more interesting example. So let's start by adding two integers, just a plus b, and then building up to a vector or an array addition. So let's say दो arrays हम eventually we'll start with a plus b, but उसके बाद हम a array plus b array equals c array करने की कोशिश करें. So again let's talk about the kernel. Again मैं kernel उस चीज को बोलूँगा जो GPU पे execute होगा, which means any function which has a global keyword before it, it will be executed on the GPU, and that is probably my kernel, right? So मान लो एक सिंपल सा है, इसमें है int a, int b, int c, तीन पैरामीटर्स मैंने पास किए फंक्शन में और मैं c equals a plus b करना, as simple as that, right? So this is the kernel function, which means it is supposed to execute on the GPU. ठीक है? So as before, global is a CUDA C++ keyword, meaning it will execute on the GPU and it will be called from the host. ठीक है? Note that we use pointers for the variables. ठीक है? अब since ये device पे run होता है, मतलब अपने GPU पे run होता है, which means ABC must point to some device memory, right? इसका ये भी मतलब है we need to allocate memory on the GPU. और allocate कैसे किया जाए? It's very simple. Let's discuss this later because these questions can be a little bit technical and take some time. So yeah, that's a good question, but let's discuss this afterwards. So it's as simple as C++ programming. If you guys have used malloc, free, memcopy, and all those things, GPU पे करने के लिए CUDA malloc, CUDA free, or CUDA memcopy. It's the same thing. It's like exactly similar. So again, the reason why GPU program is so simple, if you have C++ knowledge, you can all do all these things very easily. ठीक है, अब जब GPU पे you need to allocate memory, CUDA malloc. If you want to free the memory, CUDA free. ठीक है, चलो let's return to the function which we discussed, the kernel function. ठीक है, ये तो बहुत सिंपल है, कुछ भी नहीं, a plus b की list. Now let's look at main. मेन में क्या किया हमने, int a b c. It's very simple, तीन कॉपीज अपने CPU के लिए. अब int pointer d, d is like device copy of a, device copy of b, and device copy of c. तो ये तीन मुझे pointers बनाने पड़े because मुझे GPU पे इनके लिए मेमोरी देना पड़ेगा, right? Because I need to process it on the GPU. So तीन अलग कॉपीज बनाए. ठीक है, पहले ठीक है int का साइज ले लिया जस्ट टू allocate memory. अब मैंने ये तीन जो भी थे इसको मैंने CUDA malloc करके तीन अलग अलग अपने GPU में मेमोरी मैंने allocate कर दिया. And let's say a equal to 2, b equal to 7, just for like a setup. अब क्या करना है, अब इनको जो भी इनके वैल्यूज है इनको डिवाइस पे कॉपी करना है. CUDA mem copy host to device. CUDA mem copy host में दोनों a और b को मैंने डिवाइस पे कॉपी करना है. Oh, can you repeat this slide from the beginning or maybe from the previous slide? Okay. You mean the code? Actually, I'll go with the code. Like, actually, we will write some piece of code that makes it that should make it. Can somebody help Ritesh? Just can you post the link on the thing, Google Hangout thing? Because I'm sure you guys can listen. Yeah. Uh, so ठीक है. So let's look over the slide once more. It's a very simple C++ code. Uh, int abc in host copies. अपने abc का host मतलब अपने CPU के लिए. White. Yeah, okay. So let's for the timing, let's not get into the pointer questions. Let's just avoid because a lot of people here don't have that background. It will just go endlessly. We'll discuss these technical questions later. Let's just assume that we have uh, these. Let's just assume that we're allocating memory. Exactly. Is it? It's not. So in brief, it's not a constraint. Is it a constraint for? Okay. So let's discuss this later. Okay. So we're just allocating memory to for ए जो डी ए डी बी डी सी ऑन द डिवाइस ऑन द जीपीयू ताकि हम उस पर प्रोसेसिंग करने के लिए उस पर एलोकेट कर दिया अपने मेमोरी को एंड जस्ट टू स्टार्ट विद a equal to 2 b equal to 7 so is what kind of confusion do you have here okay ठीक है now let's copy the inputs to the device अब let's copy the stuff from your from our CPU to the GPU so mem copy host to device these are the functions जो last में parameter तुम लोग देख रहे हो उस function का so DA A DB B and size फिर as simple as launch the kernel अब हमने याद है वो add वाला function लिखा था कुछ टाइम पहले it's just launching the kernel with the three parameters A B और C जो device के copies है जब सब कुछ हो जाए copy the result back to C तो device से फिर C पे copy हो जाए and then if you want I mean CUDA free तीनों जो device पे allocated थी memory उसको free कर ताकि there is no memory leakage so चलो अब हमने दो numbers को add किया let's move on to parallel अब there's a very simple way to make it parallel जो हमने ट्रिपल ब्रैकेट्स के अंदर जो numbers है ना 1,1 go into the details the second wala one and that is for another session but the first one talks about how many number of threads you want it's actually called blocks but just for sake of explanation sake of simplicity the first number talks about kitne threads mujhe start karne at the same time so instead of executing add once n का मतलब ये n बार एक साथ parallelly invoke होगा let's just see this with each parallel invocation of add which is referred to as a block ये जो हमने n लिखा है that is actually called a block and a block हर block का एक id होगा right because you need to कि block 1 को run करो block 2 को run करो block 3 को run करो ऐसे करके so how to reference that by default ये कुछ define ही करने की जरूरत नहीं है this is like CUDA के अंदर ही block idx.x so look at this small code which I have written int a int b int c and pointers C of block id.x is equal to A of block id.x plus B of block id. So ये automatically block id अपना index maintain करेगा वो देखेगा कि कौन से नंबर वाला मुझे है कौन से नंबर का है so you don't have to worry about these things but you need to specify कि block id क्या है ठीक है अब जब चीजें होगी automatically block 0 plus c0 equal to a0 plus b0 block 1 c1 equal to a1 plus b and so on yes so this we have moved on to arrays now because they are pointers you can also put arrays there so it's like we have moved from adding two numbers to adding two arrays ठीक है अब हमने दो ऐसे बहुत सारे arrays को as a block ऐसे divide कर दिया so let all these blocks can execute in parallel ठीक है so returning to our kernel it's as simple as that कुछ नहीं किया हमने बस c of block id डाल दिया a equals b of a equals block id and b that's it now let's start let's do something exciting like this is probably the most exciting part of the session because we get to write some code is anybody writing code with me I don't think so but just in case anybody is just let me know okay nobody is so okay let me switch to the presenter view hope you guys can see the screen. Okay, in this time I want to switch on a few microphones. Can you guys switch on a few microphones for yourself, just so that I know that मैं कुछ discuss करूँ तो पता चले. Because the point is when I go back to that screen, I cannot I cannot see your comments and stuff. So maybe I can. Maybe yes. So can you guys still see the screen?
Yeah, I can.
Perfect. Awesome. Awesome. Perfect. So ठीक है. Let me start with a simple source. Uh, ठीक है. अब पता है जिसको कुछ बोलना होगा ना, हाँ ठीक है. If anybody wants to say something, just just speak on the microphone on करके. It's buffering. Oh my god. So sad. But anyway, I'll wait on the screen for a bit so ताकि तुम लोग आराम से देख पाओ क्या हो गया. It's perfect now. Yeah, I guess थोड़ा lag तो रहेगा. So this is the Visual Studio screen. बिल्कुल खाली कोड. There's nothing in this whole thing as of now. So what we're going to write is a very small
Aniket, you will have to wait.
to see कि वो कितना time लेता है. Just to get a timer of what. So मेरे कुछ नहीं है. I have like iOS 3, stdlib, which was the standard header files. There's an OMP header file. I'll talk in a bit what this OMP is. I have a small code, timer code, ताकि मैं exactly timer बता सकूँ in nanoseconds and actually microseconds. And I have a small define n equals ये कितना है 1 2 3 says 551 crore. I don't know how some yeah it's something. So it's like 51 crore kind of array I'm trying to create. Just to show that this is what big data is. Big data is not 10, 20, 1000, 10,000, 15,000. It is as big as billions and billions of it. So just to be एक example में लेके define एक कोई int कर दिया and let's start programming. So let's mouse. Yeah, it's I really want like huge. You need to tell the difference, right? Otherwise, the point is अगर नहीं करेंगे then you won't get you won't see it as big. The point behind the session is all about big data. And if I don't put big data, you guys will die. I'm trying to push the limit. And by the way, I have a very third-rate GPU, like really a very old GPU in terms of like one of the older NVIDIA GPUs available. So no, Visual Studio does not do it. I have installed CUDA on this. So when you install CUDA, then I'll show you. Wait, in a comment box. Yeah, I'm seeing it could be a buffering issue. Just bear with me, guys. Because थोड़ा time this can take some time. Okay. Let me write a piece of code first. So void main. As usual, this is a CPU code, right? So I still want to allocate memory. देखो यार, what people have asked. Got a mute, please. Okay, yeah, okay. ठीक है, so I'm just copying this 3 times. Just fill some arrays, just to अपने arrays में कुछ रहना भी चाहिए. So let's for equals 0. I'm also speaking those things, so in case you guys have any issues, you can listen to me. share the code with you. Don't worry about it. I equals 0, then I is less than plus plus. Very simple code. And just to fill up with something, let's say a of I equals random number b of I. Let's start a time. We should actually calculate a time based on the processing we have done. So increasing the screen resolution. Oh, doesn't it by default decreases? Let me try. I'm not sure if this is helpful, but if it is, it's really good. So this is a small array which we have put. Let's start the time, because again time calculation should start from the point where we are actually doing the calculation, not just this random this initial copy of the text. We already put a variable over time start equals get time. Okay, I have some. Let me quickly see what brilliant works. So let's write a small code. This is like the actual code for processing. So int I equals I is less than n plus. Okay. And it's like as simple as you guys know. C of I equals. Let's say I have a calculation a of, and थोड़ा बहुत तो complex करना पड़ता है. A square I b square. Just to make things a little more spicier. Okay. Now let's end the time. Int equals get. Now let's put it there. Let's free the memory first. Anybody have any questions for me? Does this seem like really simple, right? ठीक है, अब इसको run करते हैं. Let me see. I probably need to show you this running thing. Show stop. Oh, did I? Let me see. Oh yes. Thank you, Gaurav. Okay, that was a good thing. Thank you. Let's see अब time देखते हैं. Let's set this as the start project. I have actually created two empty projects. एक CUDA लिखने के लिए, एक just to read. चला के देखते हैं. By the way, this will take a lot of time, but the point is the actual calculation को हमने जो measure किया है उसी को देखने का हमारा goal है. Let's see this how this works out. Okay, so I've reversed. Actually, time end पहले करना चाहिए. The time was in negative because I made this one mistake. Let's rebuild this and start this. Yeah. Yeah, I get this right. how much time it takes. And let's just note down this time. Oops. Did anybody see the time? Nobody did. Let me just open up a notepad and see. Because we need to note down this time as well. So CPU version time. Okay, so we have huge number of seconds here. 9 seconds. Let's say CPU version का इतना time था. अब see the point is CPU doesn't have to be this bad, right? CPU में भी अपने पास तो 4 कोर्स है ही ना. हम लोग मेरे कंप्यूटर में तो 4 कोर्स है, क्वाड कोर सिस्टम है, तो मैं CPU को भी तो फास्ट कर सकता हूँ ना. So there is a very good tool which you guys should totally use. है OpenMP. So include OMP in your header file. just omp.h ये Visual Studio के साथ ही आता है. And what you can do is जो भी फंक्शन लूप को you want to make it parallel इस 4 कोर्स में चले, उसके parallel इतना लिख दोगे so it will automatically create threads parallelly अब तुम्हारे 4 कोर्स में. So this is a very simple way to parallelize in cores. इसमें see OpenMP is a big programming tool and I would imagine it will take a lot of time to know everything, but that's a very basic thing. If you want to parallelize a loop और उसमें independent and side calculation, so just write this thing. और ये Visual Studio में inbuilt है, मतलब omp.h कुछ library कुछ लोड करने की जरूरत नहीं है. ठीक है, now let's run this. See कुछ better होता है कि just to see that whether 4 cores give you any benefit or not. Okay, now this seems like a good. Let's set CPU version 4 cores. See, I think ये almost 3 point something times है, 3.5 3.6 times faster है, which makes sense, right? Because 4 cores है, अब एकदम divide by 4 नहीं होगा. There's a lot of overhead when you're using OpenMP. वो अपना scheduling करता है, वो भेजता है अलग जगह पे, so there's an overhead. But जो भी हो, it is almost like 4 times faster, which is really awesome, right? This is like out of the box tool which you guys can totally use. जी अपने बस 4 अलग processors में डालने के लिए. But again, you know, we are dealing with billions of data. इतना time तो हमारे पास नहीं है. हजारों कैलकुलेशंस हैं, ये तो बहुत ज़्यादा है. Let's try to write a code for GPU. किया जाए. And in fact, I think I can copy a lot of the code from this. क्या पूरा लिख देता है. Okay, so CUDA के लिए I have the same thing. I don't need OpenMP यहाँ पे, but I have to include 2 more header files. CUDA runtime.h and device launch parameters. ये automatically जब CUDA का कोई project खोलोगे तो ये आ जाएगा. So you don't have to do anything. Again, it's the same thing. I have int start end define end को मैंने कर दिया है, and I have the same timer का function. Let's start writing code now. पहले let's write void में, उसके बाद हम device को लिखेंगे. Actually, maybe we can copy some of this stuff. डिवाइस में जब करना है तो एबीसी हमने बना दिया. CUDA malloc आप डिवाइस में malloc CUDA malloc क्या होगा इसको बना ये इसका साइज एलोकेट करना है. सो n star size of dimension का n होता है एलोकेट करना है. सिंपल. I mean ये सब कोड नहीं लिखना पड़ता है, ये सब तुम लोग कॉपी पेस्ट कर करके don't need to do anything for it. तो मुझे ऐसे भी एरे फिल करना था, वो मैंने एरे अपना फिल कर लिया. टाइम स्टार्ट. लेट्स राइट द जीपीयू कोड कैसे लिखा जाए. हाँ, पहले जीपीयू कोड लिखने से पहले इसको डिवाइस में कॉपी करना पड़ेगा. सो लेट्स डू अ CUDA memory CUDA mem copy because we know कि हमें हमारा पहला गोल है कि डिवाइस होस्ट से डिवाइस में कॉपी किया. पहला डिवाइस एड्रेस 48, तो हमें ए से कॉपी करना है. और कितना उसका स्पेस है, n स्टार साइज ऑफ सी का हम लोग CUDA mem by host. ये सही है, सही है. ओह आई थिंक सही है. चलो इसको दो बार कॉपी करते हैं. साइज ऑफ एंड कॉपी डिवाइस. चलो बढ़िया. अब लेट्स स्टार्ट द जीपीयू कोड. अब जीपीयू में क्या करना है मुझे. लेट्स से मुझे एक वो लिखना है, जीपीयू का कर्नल लिखना है. कर्नल का नाम अभी डिफाइन नहीं कर रहा. लेट्स से मैंने कर्नल का नाम रखा है कंप्यूटर, जस्ट ऐसे ही. उसको मैंने कॉल किया n, 1. रिमेंबर द वन वी डिस्कस्ड n, 1 कितने नंबर ऑफ थ्रेड्स चाहिए मुझे. ठीक है, परफेक्ट. तो n, 1 को क्या पास करना है, dev a, dev b, dev c. परफेक्ट. ठीक है. स्टार्ट. मुझे इसको डिवाइस में कॉपी भी करना था वापस. तो पूरा मतलब इसको कैलकुलेशन में ले रही है. कॉपिंग वाला चीज इज अ फिक्स टाइम थिंग. सो आई डोंट वांट टू मेक calculate the time for this. So copy c comma dev c. I have a question again. See, when when we write n, does it mean uh, ठीक है हम ओके थैंक्स राजीव. आई जस्ट करेक्ट दैट. नहीं n कॉन्स्टेंट आई यू कैन डिफाइन n कहीं भी. मैंने बस ऊपर डिफाइन कर दिया. यू कैन लाइक int is an int, so you can define it anywhere, doesn't matter. ये होस्ट में डिवाइड वापस कॉपी करना मुझे आ गया. क्या होगा इसको. अच्छा जी. हाँ ये ओके. इट्स अ गुड. नाउ जस्ट फ्री कर दो सबको. पूरा फ्री. Man, I'm so bored. Then let's get. Does this sound good? कोई अच्छा जीपीयू फंक्शन लिखा ही नहीं कि हम जीपीयू फंक्शन लिखो. तो ग्लोबल as we discussed, global void क्या था, compute और के जो भी क्वेश्चन है 2 मिनट रुक जाओ. मैं सारे क्वेश्चन करता हूँ. इट्स सिंपल सर. बहुत ही सिंपल एक कोड है. सी ऑफ याद है ब्लॉक idx डॉट x. ठीक है. अभी सी नहीं सॉरी कहते a
अनिकेत, कैन यू गो लिटिल बिट स्लो? स्क्रीन में और बहुत ज़्यादा डिफरेंस है.
डिवाइड बाय बी स्टार, राइट. अगर किसी का कुछ शक है, कोई डाउट है, तो प्लीज लेट मी सी. अच्छा ठीक है, nobody has any doubt. Let me go back to the thing. So this is as simple as that, right? But इसमें कुछ तो गलती है, and I'll tell you what the गलती है. Can anybody think about there might be some problem यहाँ पे? Forget this thing. This is a different problem. But इन दो लाइंस के बीच में डू यू थिंक देयर शुड बी समथिंग? मतलब जो प्रोग्रामर्स हैं उनको कुछ कुछ आइडिया होगा. एंड समबडी हैड पॉइंटेड आउट दिस बिफोर. आई जस्ट टोल्ड कि हम लोग बाद में वो डिस्कस करेंगे. So let me just say it. So it's about synchronization. अब मान लो हमने जीपीयू पे प्रोग्रामिंग तो स्टार्ट कर दी. अब सीपीयू को कब पता चलेगा कि वो कंप्यूट खत्म हो गया, राइट? वी नीड टू टेल एक्सप्लिसिटली. जीपीयू अपना अलग से प्रोग्रामिंग करता रहेगा, बट उसको सीपीयू को बताना पड़ेगा कि हमारा कंप्यूट खत्म हो गया, अब आप आगे बढ़ सकते हो. नहीं तो क्या होगा, जीपीयू अपना अलग कंप्यूट करना चलेगा, सीपीयू का जो कोड है वो there could be a potentially asynchronous type kind of question. But wait function, I don't know when to exactly. So it's sort of a synchronous. Wait function में I don't know ना वो कितने कितने टाइम के लिए मुझे वेट करना है. But there is a synchronization function जो CUDA खुद देता है. And that function is called CUDA device. बस ये डाल दो, उसके बाद all problems are resolved. This is it. Once you do this, you would find your life much more easy because now you have control over CPU, right? कि जब वो वापस आएगा CPU पे तब मुझे दो, ठीक है. नाउ इट इज डन. जब वो CPU जब वो बता देगा कि मैंने अपना कंप्यूट खत्म कर लिया, कॉपी में लगे जब भी कर लिया, कंप्यूट खत्म कर चुका हूँ, तब वो बता इट विल कम बैक टू दिस पॉइंटर एंड फिर ये टाइमिंग एंड करेगा. नाउ लेट्स सी द टाइमिंग. नाउ लेट्स क्रॉस द फिंगर्स एंड होप फॉर द बेस्ट. Oops, मैंने अपनी CPU, sorry. I need to start make this as the start function. Let's see. These are the moments where I'm generally pretty scared. Like there is no 10 बार में से एक बार कोड में कुछ ना कुछ तो गड़बड़ हो ही जाती है. So okay, so we have the results. 54 microseconds. Let's just copy this and like compare them with just let's yeah. It is kind of holy shit. So just most people don't believe with me that ये possible भी है, but you know, that's it. That's the results which you have for this thing. Okay, now yes. Now if you have any more questions and things, we should discuss more. But yeah, this is the right answer. This is as fast as can get. If the version is 54. Okay, so I'm sure you guys had fun. I'm sure you got to learn something. If you didn't, if you have any more questions and all those things, we can definitely discuss. But let's go back to our PowerPoint. Yes, I'll send you the code when we are done with the presentation. Actually, so you've seen the hands-on session. You've seen what you can possibly achieve with the GPU. Even so, when I give you the code, you can actually pull out a lot of code and push it inside the timer code. कि कुछ लोग they won't trust me in the point that कि you know कि we should copy जो memory में copy होने वाला code उसको भी डाल दो timer के. I promise you, the whole thing would not take more than okay, sure. Arduino GPU. I actually don't know Arduino GPU कितना programmable है, but we can decide. I can see what I have no idea about that. But yeah, so the point here is if you want to push even the memory copying wala code inside the time wala code, like time compute wala code, उसको भी डाल दो, तब भी वो 100-150 सेकंड माइक्रोसेकंड से ऊपर नहीं लगेगा. That is how fast the GPU is. Like if used all the cores. चार core थे कंप्यूटर के, चारों core use कर लिए. Literally my computer was like was creating a lot of noise when I was running it on four cores, and GPU, and then you saw the GPU as well. So I mean I have I don't think so. There's any point in explaining and making it awesome. It is awesome. Uh, so yeah, that concludes today's small discussion. And but yeah, it's a traditional. It's just a trailer. So if you have, we have a lot more things which we can do with the GPU and a lot more interesting stuff. And we should definitely have more of these sessions if you guys are interested. Um, and yeah, as far as uh, feedback goes, questions goes, so we'll discuss all the questions in just a bit. Uh, in the meantime, दिस इज जस्ट द ट्रेलर. मैं यही यही मैं बोलने की कोशिश कर रहा हूँ. ये बहुत ही छोटा सा एक ट्रेलर है. अभी हमने वो n,1 वो दूसरा वाला वन पढ़ा भी नहीं. Till everything is lagging and the session going over, it's not. Actually, I just realized that maybe my screen resolution should have been lesser. Thanks for pointing that out. From next sessions, I will definitely take care of it. Priyank's question I'll just answer. Give me one more minute. Uh, so yeah, keep on giving me feedbacks. I can you can definitely contact. You guys should definitely join this Facebook group. So for all the future technology sessions or things we have, we put it on the group. So it's facebook.com/groups/technologywebinars.cp. This was started by a good friend of mine, Kunal. I'm sure most of you know him. MSPs would know him. And if you want to connect with me personally, you can reach me through my UNC address, which is ab@cs.unc.edu, and I am handling. So thank you very much. I'll just take a few questions, and all the remaining questions. Priyank asked me a question right now. मैं उसको directly answer कर देता हूँ. I'll just answer your question. So, Priyank's question is, can CPU and GPU exist simultaneously? Exactly. That is the reason it is called a heterogeneous computing. इसमें हमने सीपीयू को वेट करवाया, राइट. अगर हम सीपीयू को ना वेट करवा के डायरेक्टली उस पर ही कुछ कंप्यूट चालू कर देते, वी कुड हैव डन इट. जस्ट बिकॉज मैं अपना टाइमिंग कैलकुलेट कर रहा हूँ, मैं पूरा ही वर्कलोड जो है मैं जीपीयू को दे रहा हूँ. दैट इज व्हाई वी डिड डू इट. अदरवाइज दैट इज डेफिनेटली द मोस्ट इम्पोर्टेंट आइडिया बिहाइंड जीपीयू और हेटेरोजेनियस कंप्यूटिंग. हेटेरोजेनियस का मतलब ये कि दोनों चीज को एक साथ यूज करना. एंड यस, so that's a good feedback actually. Maybe next time I can write something which uses both of them simultaneously, and then we can see how good it is. Uh, does it answer your question, Priyank?
Yeah, yeah, it does.
I mean, in short, yes. So we can do it if that's yeah. Okay, so I think if all had a very good day, if the limit to the data we can talk to CPU, yes, it is limited by the GPU memory. Right? GPU has memory सबका दो GB, 3 GB. lot. So इसलिए you need to write a code accordingly कि वो कॉपी थोड़ा सा हो, फिर next scheduling में वो दोबारा से कॉपी. So you have to pipeline your stuff accordingly. That's a good question. We need to know what the limits of the GPU are itself. मेरा GPU although पुराना है, sufficiently अच्छा है कि इतना बड़ा. These are integers. It doesn't take a lot of space, right? Uh, does CUDA support STL? I am not sure. I don't think so. Uh, oh, thank you so much. Hands-on session made so possible. So thank you everybody. Thank you Priyank. Thank you everyone for listening. I know वहाँ पे रात हो गई and I'm sure you guys want to sleep right now. But again, मुझे feedback बहुत important है. I'm telling this from a long time. जो भी feedback हो, अच्छा बुरा, कि गालियाँ देने का मन के क्या बकवास, कुछ भी, everything is very good. Because I need to change my style accordingly कि क्या क्या होना चाहिए, क्या क्या नहीं. Today I got a lot of feedback, right? कि apparently ये जो link है काफी कुछ exactly. So मेरा ये भी था कि इस Hadoop के ऊपर I would definitely talk about a little more. Like actually I was thinking of having a Hadoop session, but again it's what's in your next session? Maybe next session we can continue with the CUDA part 2. CUDA is huge, right? But I think जब learning शुरू कर ही दिया है तो we can CUDA has extensions for Java and Python. That's right. मैं थोड़ा we would create our own. Has this been recorded? I don't know. Hopefully it has been. Oh my god. So these are so weird questions for us. So ठीक है, हम लोग let's do CUDA to the next time. We'll discuss कि क्या कर सकते हैं. And हाँ, second one to be continued. Yes, absolutely right, Prerna. So yes, I think we should could at least do at least one more CUDA session, and otherwise थोड़ा incomplete रह जाता है. There's so many things to learn, and we just touched the outline of it. So homework for us, I would say, try some CUDA. I don't know कितने लोगों के पास CUDA GPUs हैं, but definitely OpenCL. So maybe we can do OpenCL once. जिनके पास Intel के जो नए chipsets आते हैं, जो HD4000, they have web browser uses GPUs. Yes, web browsers uses GPU in a much more native format. When I mean native, वो लोग directly GPU के उसको, और वेब ब्राउजर का मेन है रेंडरिंग. सो एनीवे वो डायरेक्टली ग्राफिक्स यूजेज ही है. What you see on screen is directly a rendered outline pipeline from all those different like data from different sources. So yes, in short, web browsers directly use GPU, but they don't use CUDA or anything. It depends on पुराने वाले NVIDIA पे चलेगा. I think चलना चाहिए. So एक काम करो प्रियांक, और any of those who have it, go search your NVIDIA card on the internet और उस पर लिखा होगा कि सपोर्टेड है कि नहीं. इनफैक्ट 2008-9 के बाद जितने भी CUDA के GPUs हैं उसमें कुछ ना कुछ सपोर्ट है. बट अगेन, टू बी रियली श्योर, एक बार देख लो. ये सब तो गूगल कर लो यार, ये सब के लिए मेरी क्या जरूरत है. आई थिंक बट चलना चाहिए, आइडियली चलना चाहिए. मेरा भी बहुत पुराना है. ठीक है. थैंक यू सो मच एवरीबॉडी. लाइक आई एम गेटिंग सम रियली गुड फीडबैक अगेन. हैव अ गुड नाइट एंड ब्ला ब्ला, जो भी मतलब. ठीक है. एंड आई थिंक दिस सेशन हैज बीन रिकॉर्डेड, राइट? वो गूगल हैंगआउट पे तो रहा होगा, राइट? एंड आई विल so Google, I guess we can download that session and like maybe crop and trim जो भी करना. I'll do that. If somebody can post the link again, I can do the editing and post for folks who could not attend the meeting. ठीक है. चलो everyone, good night, bye bye, and next time. Okay, wait. So group पे सब अपना feedback please share करना. That is very critical, very 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 critical. ठीक है. I think कुणाल आज आ नहीं पाया है जो भी, but I would really request कोई feedback है इधर मुझे शेयर करो या फिर ग्रुप पे डेफिनेटली शेयर करो. थैंक यू सो मच. विच ग्रुप? प्रेरणा द ग्रुप. या ग्रुप्स डॉट टेक्नोलॉजी. मुझे पर्सनली में यू कैन शेयर, बट वो ग्रुप्स पे शेयर कर दो. दैट इज group/technologywebinars.cb. I will share everything. Don't worry. There is nothing. I have ये तुम्हारे सामने कोड लिखा है, so you can put it on your own. It is not. You've seen, right? It's like 10 lines of code. It is absolutely nothing. Chalo guys. Good night.